अभी बंद है। हाँ
बता देना जब बात करेगा।
मेरे हिसाब से कैलकुलेशन तो मेरी सही है, परफेक्ट है। हैं? तो मैंने शीट बनाई।
मेरे हिसाब से हमने भी बनाई है शीट।
और दीपक यहाँ पे कैल्सी है क्या?
ठीक है, बट बस जस्ट यही रीडिंग्स आ रही ना। ये
पूरा दिन लगता है समझ नहीं।
follow the process, at least first. मतलब वो कंसल्टेंसी वाली प्रोसीजर को फॉलो करना।
Okay, I'm starting the session now. Just presenting my screen now. Please let me know whether this screen is visible to you or not. Once again.
Yeah, it's visible.
Okay. So welcome to the third assignment session on NPTEL course Engineering Hydrology. So in this session we will be looking into the concepts like forms of precipitation, how many type of precipitation which are occurring in a region, then how we can measure the rainfall, then how to decide the optimal number of rain gauges which should be there for a particular area. Then further we will be covering some numericals based on rainfall data. This data itself will be from a point station, that is a rain gauge only. That rain gauge may be recording or non-recording depending on the condition. So to begin with, the first question is Ashish?
Yeah, I can see it.
Okay, so the first question is, the standard Siemens type rain gauge has a collecting area of diameter. Okay, so firstly, are you familiar with this Siemens type rain gauge? So firstly, let me know whether it is a recording or non-recording type rain gauge.
It's a non-recording type rain gauge.
Okay, that's good. So it's a non-recording type rain gauge. So definitely, why is it non-recording? You may be knowing this.
Yes.
Why?
Because it's not data is not recorded in the system.
Okay. Yes.
You have to physically measure the data.
Right. Good. So at every 8:30 a.m. in entire day we are measuring the data. Okay, and that will be giving a cumulative rainfall value for entire 24 hours. So now the thing is, the Siemens type rain gauge, what will be its diameter? So basically it's a Indian standard, okay, that have decided the diameter of this particular rain gauge. I guess anyone is joining. Let me see. Ashish, can you see anyone is joining or maybe okay? Balamurugan is replying. Okay, no issue. Coming to
No,
this.
only we three are there.
Okay, okay, good. Okay, Ashish, tell. Okay, if you are not having
Yeah,
a
I don't
proper
know this.
explanation, then definitely we will be going into the actual explanation which is associated to this. So you can see from this picture itself. So this is a Simon type rain gauge. Okay, you can see a funnel which is operating here. It is collecting the entire rainfall which is occurring in the region. Now it is having a dia of these all entire units, they are in mm. Okay, so this is 127 mm. So the diameter of this collecting bottle that has been asked, so it is having 127 mm of dia. So definitely the options which are associated, so definitely you will get 12.7 centimeter. Okay, also you should know that what is the height of this collecting bottle. So it is 305 mm. Okay, so the whatever the rainfall coming into this, it is getting collected inside this bottle, and then we will be having some measuring flask. So we will be putting this water and try to measure that the cumulative value of rainfall occurred in the region. Okay, so you can see for your further information that this rainfall is measured every day at 8:30 am and is recorded as a rainfall of that day, like 24 hours. Okay, now one more thing is there, that is area. So you should know that based on the IS standard, that is this IS 50 to 25 in the year 1969, it gives entire detail about this rain gauge. Okay, and it also mentions that this type of rain gauge comes with two variable areas, like it could be 200 centimeter square or one other will be 100 centimeter square. Okay, now coming to the next question. So the question here is, the standard recording rain gauge adopted in India is of. So it is asking recording rain gauge, and that is adopted in India.
Um, Tipping bucket type, I think so.
No, it is a natural siphon type. Okay, so
Okay.
it's a natural siphon type. So we will be look into the explanation. So we will be in this explanation, we will be looking into each recording rain gauge which is mentioned in the option. So firstly, going with the natural siphon type, so definitely IS standard 5235 1969 gives the entire information, like information in the sense it is of about area, then the dimension, and then some maintenance and major uh, care that we have to take while we are uh, like locating this rain gauge in the area. Okay, so it is also called a float type rain gauge. So rainfall collected by a funnel shaped collector. Okay, it is taking the entire rainfall, okay, from the funnel into a float chamber. Now Ashish, do you know the working principle of this, that how is it working?
Yeah, its working principle is that water get collected into the funnel and then it goes down.
Yes,
Then the due to the this piston, like piston, what we say,
yes, right. So
it
this
increase and we'll get the reading on the graph.
exactly, yes. So basically whatever the this lever system is attached, okay, pen mounted on the lever system. It is attached with the float. Okay, so as soon as the water is coming in this particular float chamber, so due to the buoyancy effect, it is going upward, and therefore this pen, whatever attached to the lever, it is also moving up and down. Okay, as and once this entire float chamber is entirely filled, then based on the siphon kind of principle, entire water contained in the float chamber, it will get away. Okay, and then again the this point marker that is there with the pen, it will come down to its original point. Okay, so this is the thing. Now some more information, like this siphon arrangement, this is basically empties the float chamber. Okay, the main thing is of this siphon is that to empty the float chamber when it get entirely fulfilled. Okay, now you can see further information that after getting a chart from this natural siphon type rain gauge, so we are getting the graph like this. Okay, so what we are doing in this, we were already did this kind of work in our observatory in IIT Roorkee. So for this, what we did initially at 8:30, we used to put this graph in this natural siphon type rain gauge. Okay, so these lines are not there, it is entirely no graph is there. Then if there is a monsoon kind of season is there, then definitely the graph will go, pen will be drawing like this, and then as soon as the float chamber get fulfilled, then this pen based on the float, okay, like based on the siphon principle, water is getting emptied. Okay, so then suddenly this pen, whatever the pointer here, it will finally come up to the bottom. Ashish, getting the point or not? Then again it will get refilled, it will get likewise it go. And you can also see from the graph, you can also see whenever this line is getting flatter, okay, or it is getting constant, then it means that there is no precipitation. Okay, there is no rainfall is going. Now you how you can get the rainfall, like cumulative value of rainfall. So Ashish, you can also calculate from yourself and tell me whether you are getting the 53.8 mm in 30 hours or not.
30 or 50. Yeah, I got it 53. Yeah, 53, 54 in between.
Good. So this is the way how we are getting the data for a recording type of rain gauge. Okay, but keep in mind that we are getting the data at hourly scale. Okay, but in case of non-recording, we are not getting, we are getting on a cumulative value out of 24 hours. Okay, so you can also see one more thing, one important line is there, that natural siphon type recording rain gauge gives the mass curve of the rainfall. So Ashish, you may be knowing the region that what do you mean by mass curve? Okay,
it's a accumulation of the rainfall.
Yes, so basically mass curve of the rainfall is just a graph, okay, that is representing the cumulative value, okay, that is summation of P, you can say, okay, in the y direction, and then it at the x-axis it will be a time. Okay? It may be in hours. So it is representing the graph. So definitely you can get the idea that this graph will be going upward only. Okay, and maybe at some point it may get flatter also. Okay, got the point? Because it is just a accumulation, like you can whatever the graph it is going, you can keep this graph as like this. Okay, you are increasing like this, and then for the third part also, then it again going like this, so it is cumulatively going upward. Okay, now one more thing before finishing this concept. So vertical line correspond to the sudden emptying of the float chamber. What I told you, that whenever this vertical line is going, so entire float chamber is getting emptied, and then pen is coming to the zero level. Okay, the question next comes is the following recording rain gauge does not produce the mass curve of the precipitation as recorded. So it is again asking about the mass curve. So firstly, you should not be confused with the concept that a mass curve is nothing but it's a cumulative value of p with varying with the time. Okay, time may be in hours. Okay, so it is asking. So Ashish, do you know the name of all these mentioned recording rain gauges? Like one is it's not like Simon is not a recording, you may be knowing this. Okay, but the remainings are this natural, weighing and tipping bucket. They all are the recording type of rain gauge. Okay, so tell me that the recording rain gauge which is not producing the mass curve.
Following recording is, I think, weighing bucket. No, no, it's tipping bucket. I think
Yeah, right,
it's
right.
tipping bucket.
Yes, yes. So the tipping bucket type of rain gauge, it is giving a total rainfall. It is giving a entirely a total rainfall value. Total rainfall. Like you can also compare it with like a similar kind of Simon's rain gauge principle. Okay. So we are not getting the rainfall value at every interval in the sense 1 hour, 2 hour, 3 hour. We are getting only a cumulative value, that is it is getting giving a total rainfall. Why is it going like this? Because in tipping bucket kind of thing, there is two buckets are like attached at a single balance. Okay, and whenever the rainfall is coming, then one is getting filled but the other one is going upward, and once it get filled it will empties the water, then again it will go upward and then it will take the water. So basically based on this balance kind of thing, it is giving a total rainfall. Okay, now the remaining one is like bagging bucket type rain gauge, then natural siphon type of rain gauge, they are providing the mass curve. So you can see the description also, like why tipping bucket is not giving a mass curve. So basically tipping bucket is US Weather Bureau adopted rain gauge. Okay, it is having a dia of somewhat 300 mm. Then the catch from the funnel fall into one pair of the small bucket, as I discussed. You can see, Ashish, you can see there is a pair of buckets. Okay, so it is working on to and fro condition. Whenever the water is falling in this particular, so it will get weight, so it will be moving downward and other one is going upward. Now the one more thing you should know that how much water could be stored in each of the bucket. So it is 0.25 mm. Okay, 0.25 mm can be stored at a one time in a one bucket. Okay, now water collected in the storage is measured at a regular interval to provide the total rainfall. Okay, so it is getting a total rainfall only. Now in continuation we can also see the weighing bucket principle. So Ashish, firstly you have to look into the picture that this is representing a weighing bucket type rain gauge. Why is it weighing? Because there is a spring balance attached. Okay, so there could be a principle of weight. Okay, that is mg will be acting in this, and there and definitely there will be some reaction force, that will be kx. So based on this balanced kind of thing, w equal to ks, it is giving a value. It is basically you can see whenever the spring is moving up or down, then there is a pen added to the lever. It is moving up and down. Okay, this is a graph. Okay, so again the siphon kind of principle is where, not an exact siphon, but yes, the graph part which is basically we are following in the in the siphon rain gauge, the similar kind of graph we can obtain from this also. Okay. So it is also giving a master of the rainfall. Now the next question is the term used to describe a line on the map that represent equal amount of precipitation. So the thing is equal, or we can say constant amount of precipitation is there.
It's ISO heights.
Yes, right. So it's ISO heights. Okay. So can you tell the meaning of isotherm?
ISO it's I think graphical representation of rainfall.
No, from the thumb use itself you can also get that it is related to the temperature. Okay.
Okay.
So you are getting the constant value or equal amount of temperature only.
Okay. Got
Okay. The
it.
similarly isobar is there.
Pressure.
Yes. So here you can see that constant pressure will be there. Okay.
Hmm.
So just for an addition, it is for additional information only.
Hmm.
So yes, ISO heights are there. So you can see from this picture that there is a watershed boundary and we are getting the ISO height. So entire in this region, from this, like from A to B, this part, we are getting the equal rainfall only. At every point we are having the rainfall of 8 mm only, 8 mm or maybe 8 centimeter, anything. So similarly for 10 centimeter we have, then for 6 centimeter. And how we are getting this? So you can see this is a basically contour of constant rainfall in a given period. Okay. And how we are getting this? So we are getting this by interpolating the rainfall data at a gauge point. So Ashish, you can see this is a gauge station and we are getting the rainfall, cumulative rainfall of maybe I guess 12 centimeter I can take. And if I am interpolating this, so I can obtain the 10 mm. Even here you can also assume an ISO height of maybe 11 mm. Then further you can also assume 12 mm. So likewise we can get this. Okay. So the important aspect of this, I can say use of this, is that we are getting the spatial distribution of rainfall data. Okay. So initially we are having some kind of region where we have located the rain gauge, and now we want to interpolate, like we want to know the effect of this particular rainfall in this particular maybe you can say r distance. So how you can get this? So at a r distance, what will be the variation of what will be the effect of this rain gauge? Okay. So we can get this. So it is saying that spatial distribution of rainfall data. Okay. Ashish, should I move ahead?
Yeah. Yes.
Okay. Now comes to the question, numerical part now. So the first question is, this question is firstly I should explain this. So here it is saying that a catchment area has a 7 rain gauge station. Okay. So already for an area 7 rain gauge station are installed. You can say 4, then 5, you can say 6, then yes 7. So 7 stations are there. Okay. Now it is saying that in a year annual rainfall recorded by the rain gauge is as follows. So annual rainfall value is given for each point. So for P it is 130, then likewise it is varying, and for V it is 146.9. Now it is saying that if we are counting a 5% error in the estimation of the mean rainfall, we have to determine that how many rain gauge additionally we need in order to maintain the rain gauge density, okay, in that area. How we can obtain this? So it is just representing the adequacy of rain gauge distribution. Okay. So you maybe studied the concept this.
Yes.
So now you have to determine the additional station that may be required in this area. So firstly we have to check that how many rain gauge station we need. Okay, so in order to get the number, do you have any kind of information that how we can proceed?
We have to check the, I think, coefficient of variation.
Yes, right. So if we want to calculate the number, then definitely we should calculate the coefficient of variation. Variation in what? Variation in the rainfall. Okay.
Rainfall.
And that will be dependent on the standard deviation of the rainfall. Yeah, how the rainfall values at different rain gauge station, they are basically varying from the mean value. So we have to calculate this, and then we will be utilizing the error percentage that has been given to us, and we are giving a square of this. So based on this, we will be counting that how many number of rain gauge we need in this catchment. Firstly we are counting this, and then if let's say if we need maybe 16 rain gauges, okay, if we are getting this, so they have already provided how many? They have provided 7. So remaining will be what? It will be additional stations only. Okay, so Ashish, if we want to calculate the CV, how we can proceed is, so we
We
have
need to find the mean first.
yes, right.
Then we have to see how much the value is deviating from the mean.
Right. So we will be computing the standard deviation first for m-1 number of rain gauge station, and we will be dividing this with average precipitation. Okay. And multiplying by it by 100, because entire whatever the value we are taking, it will be in percentage. So this E value, it will be in percentage only. We will be taking in percentage only. And now for this CV value, we use this standard deviation concept. Now firstly we have to compute the P average value. So can you tell me the average value of this?
It's 130.43.
Okay, 130 point for entire na, for from P to V.
Yes, yes, from P
Okay.
to V.
So you may be adding all these values and dividing it by 7, right?
7. Yeah, correct.
Okay, so you are getting the value of 130.
0.43.
130.43, it is in centimeter. Okay, now you have to also calculate sigma m-1. So there is one formula that based on the statics only we have got this formula. So it is square root of, can you tell the formula?
No, I don't know.
Okay, so square root of, basically as from the name itself, it is talking about the standard deviation, right? So how it is deviating? So we are basically this entire standard deviation concept, it is coming from some kind of data distribution principle. Okay, so basically as the from the concept only, there is a Gaussian distribution for any kind of data we have. Okay, so this dumbbell shape of shape is there, and at the mid, sorry, again, okay, sorry, where is this? Okay, okay, you can see the data. So mid of this, it is just a, you can say it is a mean value. Okay, P bar, and how it is now other values, how they are deviating from here to here. Okay, left or right? Sorry, this will be right. Okay, so how it is deviating? So definitely the formula will be, it is since we are considering the deviation, so P minus P bar, okay, to the square divided by m-1 number of stations. Okay, so now you have already calculated the P bar value, you also know the P. Now you have to compute what about them. M is simply what? M is 7.
7? 7.
Yes, right. Now you have to compute the sigma value, sigma m minus 1.
And what is the formula? This.
Yes,
Sigma.
square root of okay, let me write here again.
Yeah.
Square root of p minus p bar
P
to the whole
minus
square divided by m minus 1, entire square root. Okay,
okay.
yes.
So P is the total.
P is this value, actual value, this one.
So we have to calculate for each station.
Yes, right, you are right. So definitely then again at the last we are taking the summation of this. At last
Okay,
we will
okay.
take the summation of this value. Okay, so you can see this is the formula for getting the optimal number of station. Okay, with certain degree of percentage we are computing, we are accepting this, and now how we are getting the CV value, coefficient of variance. So we are dividing standard deviation with mean precipitation or mean rainfall. Okay, and how we are getting the sigma m value. So you can see the formula. Okay, so it is a square root of entire summation we have to take again. P minus p bar to the whole square divided by m minus 1. So how we are computing this? So Ashish, you are right that we are getting the average value of 130.43. Okay, and what about the standard deviation? So if you can calculate, that will be good. Okay, because definitely you will be getting a problem in calculating standard deviation only, because computing the average value is much more easier. But now the task is like once if you are getting the correct value of sigma m minus 1, then you can easily compute everything. Yes. Let me see whether okay, good. Yes, mean value you are right. Good. Nice to see, Balamurgan.
0.1 नॉर्मल कहाँ से लिया था हमने?
Okay, Ashish.
Okay.
So once you get the standard deviation value, so you are computing the coefficient of variance. Okay, and now you are getting the value of nearly 16. Right?
16%. Yeah.
Yes. It is in percentage, right? And then we are computing the minimum optimal, we can say, or you can say minimum rain gauge we required in the region, we required in the catchment. So we are getting nearly 9. Ashish, it will be good if you can calculate this. I guess this is not a problem. I guess
Which
one
one?
or two
The
values.
standard deviation?
Yes. Don't bother about this. Ignore this for time being.
Yeah.
Compute this only for every for P, then for Q, then
1
R.
minute, I'll calculate.
Yes, because it will be good only, na. The entire thing it is written on the screen. That's a good version that you are getting a reference of this, that what is the actual answer. But it will be good if you can calculate by yourself.
Yeah, we can calculate it. No, sure.
Okay, so if we will calculate for P, if we are calculating sigma, I guess I can say sigma P. So what will be its value? So it will be no, for we are don't consider P, take it m minus 1 only. Note this. Now what will be the proper setup of this, that 1
एक बार check कर ये किसका रखा है
130 minus, how much value was coming? 130.43, right?
Yes, yes, yes.
Okay, so we have to add this is for P, then again 142.1 minus 130.43 to the whole square, then again this is for Q, then again 118.2 minus 140.3, it is again a square, it is for R value. Okay, then 108.5 minus 140
अरे नहीं
140.3, again it is a square, this is for S. Then similarly we are adding for the T also, so 165.2 minus 130.43 whole square, this is for T, right?
Mhm.
Then 1
So
130.43.
0.001 minus 130.43.
Okay, now entirely it will be divided by m minus 1. This will be square root for entire terms which are written here.
Mhm.
So once you get this, so m minus 1 will be what? It will be a 6 only.
Yes, yes.
Balamurugan, are you getting the value?
Yes, Guruji. God bless you.
Okay, you are getting. It will be good if these values are matching, because the thing is that you should be getting the answer. Okay, it is for your reference, it is for your proper or maybe good understanding. The calculation is easy if everything is provided here, but yes, whenever you are giving or maybe you are writing an exam, definitely you will be having maybe 2 or 3 minutes for the same question. So it will be good if you are getting the speed up the things parallelly. Ashish, are
Yeah,
you
yeah,
getting
I'm
somewhat
calculating it.
16 or something? Okay, yeah, calculate it. Do you know there is one provision also for there are some proper guidelines they have been provided from Indian standard conditions, and then parallelly it has been provided for world level, that is from WMO. So they have provided the rain gauge density. Okay, so basically it's a kind of minimum rain gauge that is required for a certain area. So they have already specified these conditions, and these conditions may vary from plain to hill. Okay,
So we are getting 0.48.
okay, you are getting 0.48 what? Sigma m minus 1.
No, no, no. 0.48 square we need to do. So under root of 0.230 divided by 6.5 divided by 6 under root of 1, sir. No.
You are
We
not getting?
getting it's okay. We have to multiply by 100, no? Okay.
Yes.
Yeah, I'm getting 19.59.
Okay, okay.
the value of sigma n minus 1.
Okay, 19 point.
59.
Approximately it is getting 20, closer to 20, right?
Mm-hmm.
Yes. So once you put this 20 in
Yeah.
calculating the coefficient of variance, you will be getting 16. Okay.
Yeah, let me 20 divided by 130.43. Yeah, it's 16%
Good.
around.
Okay. Now you can compute the n value also.
Hmm. The n value is CV square divided by.
No, CV upon E. Firstly calculate CV upon E, then
Hmm.
take square of that
Oh,
value.
E is 5%. Okay.
Yes, E is 5. You are right.
16 divided by 5
E is
square.
just an error that may be encountered.
Hmm. Hmm.
Okay.
16 divided by 5, we say 3.2 square. We are getting 10.24.
10.24. I guess. Yeah. Based on your value, it should come maybe 9. Uh, but yes, if you are getting 10, okay, you can also check your calculation later. Okay.
Yes, if we
CV
multiply.
upon E, like CV, it will be if it is 16 or upon 5. Okay, so definitely you will be getting not 3.5, but it will be this, and then 3.2 you are getting, na? Square of this.
Yeah, if I calculate CV as 15.5, 15.5 divided by 5, it become 3.1, and square root of 3.1 become 9, around
Yes,
9.6.
yes, yes. So nearly it should come to 9, and
Yeah, yeah.
one now we already provided like 7 gauges have been already provided in the catchment. So they are asking that how many additional rain gauge we need to install.
Mhm.
Okay, so it will come 2 rain gauges. Okay,
Mhm.
so we are moving ahead now. Again, the question comes. So this question is related to find out the missing rainfall value. Okay. So what it is saying that there is a catchment and 4 or maybe 5 stations are there. So P, Q,
Mhm.
R, S, T. These rain gauge stations are there. Okay, and they
Mhm.
are having the normal annual precipitation. So do you know? Do you familiar with this term? Normal annual
Mhm.
precipitation.
Yes,
So what is it?
it's a 30-year average data.
Yes, average of 30 years data. So this is there. So it have been provided for all the stations. Now it is talking that it is saying that for a particular storm, the precipitation values were noted for P, for Q, for R, okay, and for S as well. But for T it is missing. So P precipitation, you can consider it like this in this abbreviation. P at T is missing. Now
Hmm.
they are asking that we need to calculate the rainfall at T station during that this storm.
PQRS
So do you
is
getting any kind of idea that how you can proceed, how you can solve this? Like firstly, you should note the data. Like if we write it as like given data. So what data we have? So normal annual precipitation. So NP is provided, NQ is provided,
Mhm.
and R is provided, and S is there, and one more is there. And yes, it will be NS, then NT is there. So we have this data also, and likewise we also have precipitation value for PP, PQ, PR, PS, but PT is missing. So, can you find any kind of relation which can
Yeah, we
let?
have to apply
Yes,
formula that normal rainfall method formula.
yes, good, good, Assis. Yes. So we need to apply that formula, okay, and based on that we will be calculating the missing rainfall value. So firstly go through some basic concepts. So yes, you are right, Ashish, that normal rainfall value what have been given for the stations.
Hmm.
So it's a average value of 30-year period, and then you have some idea that what is the basic difference between simple arithmetic average as well as the normal ratio method. So Ashish, there is
Hmm.
one difference that when this methods can be useful. So you can see that it is mentioned that whenever the normal annual precipitation at various stations they are less than 10%, okay, it is asking that if we take NP value, NP minus maybe NQ, okay, and we are finding the variation of this maybe with reference to NP and only I am taking. So if it is coming less than 10%, then we can adopt this simple arithmetic average method. But if it is getting more, like variation is getting greater than 10%, then we have to utilize normal ratio method. Though it may be possible that uh, we may have the normal annual precipitation while we are using the simple arithmetic average. In the question itself you can get the value, nx is there, but you should have some idea that where this particular method will be applicable. So now from this you may be having some understanding that where we have to apply the normal ratio method. Okay,
Hmm. Got it.
got it. Well, then good. uh, okay, now I want, don't go with this answer directly, okay, Ashish.
Hmm.
Instead, firstly, try to compute the variation in NT. NT in the sense what? We need PT value, right? Ashish, is it
Hmm.
right or not?
Yeah.
We are looking for the precipitation at rain gauge station T. So just
Hmm.
in the previous, from this previous slide, we should firstly confirm that which method we can opt. We can opt maybe a simple arithmetic also or normal ratio. But the thing is, firstly we have to compute the variation in NT. This is important. Now, how the normal annual precipitation at station T, it is varying with respect to station P, with respect to station PU, R and S. Firstly, we will be computing this. If all these variations, it is coming less than 10, then we will be going, we can easily go with the arithmetic method. Okay,
Hmm.
but if any one of the value, it is going more than the 10%, we have to take the normal average method, okay, normal annual precipitation method. Got it?
Hmm.
Yes. So now you can see the things that what the values are coming, is it matching with you or not, like for NT, okay,
So
you
NT
already,
is 137
yes,
divided
values are
by
already listed here, you can take for your reference, okay.
minus
Balamurugan, I also want
125
you to check
into 100
your
divided
answer
by
with this.
137. So first one is correct,
Okay, good,
8.76.
good.
137 minus 102 into 100 divided. Second one is also correct.
Okay,
So yeah.
okay, first one is correct, then
Hmm.
second one is also correct. Wait a minute, Balamurugan, check the
Oh.
formula. M should not be used in, okay.
Yeah, M is I think yes.
You put M instead of M minus 1, sir. Okay, in that formula. Okay,
Yeah, yeah. M
okay,
should be
okay,
I think 5.
okay, okay. So why it should be m we were having, you put m instead of m minus 1, sir. Okay, got it. Okay, he is talking about adequacy of rain gauge station, right?
Mm,
In this case,
no, no, this is correct, I think.
m minus 1 I put. What he is not getting that thing. It is right, m minus 1 only we have taken.
That means the concentration of
Ashish, you were getting m minus 1 m we were having 7 only now.
Yes, that's correct.
Yes, yes. So m minus 1 will be 6 only.
Yes.
Okay.
जहाँ पे कार्बोनेटेड रॉक्स होंगी वहीं पे कार्बोनेटेड बाइकार्बोनेट
Is he talking about this m?
Yeah, this M, this M.
Okay, this m should be what? M minus 1.
No, this should be M.
This should
But
be
in
okay.
yeah, but in numbers we have taken three in the answer. Could you move
Okay,
forward?
okay. Yes, yes, yes. Wait a minute. Wait a minute. Okay, we have taken 3. Okay, okay. Got it. Got it. Got it.
We should take it, I think, five.
Right. Yes, 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 yes. Okay.
Should be.
I'm correcting here. Okay.
Yeah.
So it should be like whatever the values it is coming inside the bracket, we have to take this 1, 2, 3, 4. We have to take 4 values only because we are concerned with the remaining one, na?
Okay, okay,
How many
okay.
stations we have? 1, 2, 3, 4, 5, right? So fifth one we want, so definitely we have to take the remaining one. So m will be 4 only. Okay, I'm correcting it once again. 1, 4, and I'm saving it here. Okay. Thank you, Balamurugan, for letting me know the error in this.
Hmm. Yeah.
Okay, are you getting the value or not?
We'll calculate it. Just 1 minute.
So I guess this value will also get changed, I guess. Is Balamurugan getting the answer or not? Okay, P1 upon N1 is self-weight, got it. So Balamurugan, tell me your answer.
Number 4.
सेम टाइट्रेशन से तो जो इस पॉइंट पे हमें मिलेगा वो ठीक है और उसके साथ जो है कैलकुलेट करने का फॉर्मूला अलग था
Ashish, I want answer should match with Balamurugan also.
Sure, sure, sure.
Yeah.
Just 1 minute.
0.5 द वैल्यू ऑफ टाइट्रेशन 0.5 ये बता रहा होगा जब ये कलर चेंज हुए
12.32 mm.
Okay.
Centimeter. 12.32 centimeter.
Centimeter. Okay. Let Balamurugan confirm this. Balamurugan,
Yeah.
I'm waiting for your answer so that I can confirm.
ठीक है उसी को ही आगे बढ़ाना उसी को आगे बढ़ाया और ऐसे कलर आ जाता था उसी को आगे बढ़ाना तो सेम सॉल्यूशन में ऐड मिक्स इंडिकेटर हां दादा इस पॉइंट पे हम मिक्स इंडिकेटर डालना है ब्लू कलर होने के बाद हां सर अरे इधर आओ कलर लेस के बाद मिक्स इंडिकेटर कलर ब्लू हो जाएगा ब्लू होने के बाद में जब टाइट्रेट करेंगे तो ये रेड हां फिर ये
Okay, he's saying he's getting value of Balamurugan 51.44. No, it won't be possible, I guess, because it is getting like from the data we already have. It
It's
should.
12. Yeah, it's 12.32 centimeter.
Yes, you are correct little bit. But still I am not having a confirmation, so just I was waiting for Balamurugan's reply. Balamurugan, I don't think it should come 51 something. 51 centimeter is too much. It should be it should be in the range of other values only. Just we are getting the value of 13.2 for the rain gauge station at P, Okay, likewise we are having minimum value of 6, so definitely it should range between 13 to 20 only, it should be there. NT is 137, sir. Okay, yes, NT is 137. Yes, so I taken 137 here.
एक बार हम अपना सैंपल कर लें सर 7 मिनट
Ashish,
Yes.
can you see what Balamurugan is Balamurugan want to say? Like he is saying NT is 137. What do you want to convey? I'm not getting right now.
90 means average, I think average. No, not average. Okay. No, no.
Okay, for time being, I guess uh, I'm taking your value, what you just mentioned, Ashish.
12.32 centimeter.
12.32 centimeter.
Yeah.
Okay, Ashish, you can also just a minute. I can also calculate from my side, so it will be confirmed.
Sure.
Yes. So 13.2 which is divided by 125. So we are getting the value of about. For the first part, you are getting 0.1056, right?
13.2
13.2 divided by this, then
0.105, 106.106. You can.
yes, I can take 9.2 divided by 102, so it is coming 0.09, I guess. I can take.
Yeah,
Another value
0.09.
will be 6.8 divided by 76. I just want there should not be any kind of confusion.
0.089.
Right?
Yes.
Good. Then again go with the 10.2 value. 10.2 divided by 113. We are getting value of 0.09 again. Okay.
Yeah.
So
This
in
this
total,
this.
total value will be how much? 106 if I take plus 0.09 plus 0.09 plus 0.089.
Yeah. This mistake I did. It's the wrong value.
Okay, how much total you are getting?
Mm,
0.375?
Yes.
Huh? Like
Yes. 0.375.
what I am getting, I am just presenting here. Maybe Balamurgan can also get, he can also assist in case I am getting wrong. Okay, so here
Yes.
13.2, this value I am getting somewhat 0.0, sorry, 106 approx. For this value I am getting 0.09. For this I am getting 0.089, right, Ashish?
Right.
Okay, and then last one also 0.09 only,
Yes.
right? So sum of these values, how much it is coming?
0.375.
No, no,
One
no, only
minute.
sum.
1 minute. Point 375 only some. 0.376 you can consider.
0.30. Yes, right. I am getting the same value. What you are saying? 0.
375.
Yes, 0.375 I am getting. Yes, and then now I have to multiply 137 divided by 4. This one.
Yes.
So how much you are getting? Now tell me the answer. I am getting
12.86.
12.84.
Yeah, 88486.
Yes,
Yes, correct.
so it is coming 12.84 centimeter.
Yes, yes.
Okay, so this is the answer. Balamurgan, I hope you got the calculation now. I also got it. Okay, good. Now I am moving ahead. Wait a minute. Yes. So the next question is again it is related to missing rainfall only. So we are having a normal annual rainfall value have been provided for the station A, B and C. Here in this case they are saying that the B station, okay, it was getting inoperative, okay, maybe some climatic error or maybe some disturbances in the field, it is getting inoperative now, and they want to calculate, they want us to compute the rainfall value at B station. Okay, so what they have provided, they have provided the NA, that is normal annual rainfall for A. Ashish, you have to calculate and you have to tell me the values. Balamurgan also. NB we are having 180 centimeter, then for NC we are having value of how much, 150 centimeter. So for coming to the precipitation, so like in the year 2000 they are saying that PA value, they are getting the value of about 150 centimeter. Don't confuse with this value because it is annual value, annual precipitation they are saying. Now for B they are saying that they don't have the value because it was getting inoperative now. And for C, so we are getting precipitation of about 135 centimeter. Now again Ashish, firstly you have to confirm the percentage variability of normal annual rainfall. Firstly we have to see that whether it is greater than 10% or maybe a less than of 10%.
So we do 180 minus 175 divided by 180.
With reference to this only. Yes.
180 minus 175.
Yes.
5 divided by 180 into 100 is 2.7%. First one is.
Okay, A to B you are taking, na? Okay, sorry,
Yes.
B to A you are taking. So it is coming how much?
2%, 2.3%.
Okay, 2.3%. Okay, then
2.7%. Sorry,
okay,
2.7%.
2.7%. Good. Then again you have to calculate NB
For
to C.
So C is
30.
30 divided by 180
Yes.
into 100. It's 16%. So
Yes.
we have to go
Yes,
for another formula.
normal ratio method only we have to take because it is getting greater than 10%. If one of the value is getting greater than 10%, then we have to adopt normal ratio method only. Okay.
Yeah.
So now go with the formula and calculate the value, missing value. So here we will be computing PB. So PB will be how much?
Yeah, he also get the right answer. Balamurgan also get the right answer. 12.86 centimeter.
Good. Thank you for letting me know. Now PB, how we are calculating? So we will be having value of NB divided by 2 stations.
Yes, 2 station. Then
Right.
we do
Then
P1
PA upon NA you have to take, and then
150
P of C upon
175
NC.
plus
So
135 by
we are
150.
getting 180, so 180 divided by 2, then precipitation PA 150 divided by NA, that is 175, plus PC, that is 135 divided by how much? NC, what is 150. So compute this value.
1 minute. Into 90. It's 158.
Okay, so you are getting
158.142.
okay
143
143. It will be in centimeter.
centimeter.
Okay, so let's check. Yes, you are right, Ashish. You got the right answer. So once while solving the questions, if we are getting the correct answer, then excitement will be at some other level, right? Yes. Okay. Let me know whether Balamurgan got the answer or not. Should I should proceed further?
He get 150.14. He also get correct answer.
Good. Okay. Nice to see. Okay, further now we are moving ahead for computing the aerial average rainfall. Okay, now look at the question. It is asking that if we are having a drainage basin of about 600 kilometers square. Okay, now for that area, at any instant we may be having a point rainfall data. So you can assume that these are the stations, and based on interpolation values they have plotted the ISO heights. So now they are talking about the ISO height. So they have given the information about isoheightal values. So for 92 kilometers square of area, you can say if it is like 92 kilometer square of area, so they are saying that ISO height value, so I can assume it as P1. So they are saying it is varying with the range of 15 to 12 centimeter. Similarly, for area of 128 kilometer square, precipitation value they are saying it is varying in the range of 12 to 9 centimeter. Okay, and then for 9 to 6 centimeter ISO height interval, Ashish, are you getting the thing? Like if it is having 6 centimeter of ISO height, then other one is 9 centimeter of height, so they are saying that area between them is how much?
128 kilometers square.
120 kilometers square. This one I am talking about, this one.
Okay, 120, yes.
Yes. So you may be getting the idea that what the things are provided in this question. Now I want to ask one more thing, that how they are measuring the area, how they may be measuring the area. And do you know any kind of instrument do we have so that we can directly measure the area?
We generally use our AutoCAD tool to measure the areas.
Okay, yes, that is a, I guess it is a software based technique. But if we prefer, there is a one instrument called planimeter.
Okay.
Do you aware of this?
No, I'm not.
So using this, we are measuring the area. So now, Ashish, what we are here to compute, we need to know the average depth of precipitation over the catchment. So basically, they are asking about aerial average rainfall. They are asking. Okay. So they are asking about this. Ashish, can you differentiate between point rainfall as well as the aerial average rainfall?
Point rainfall is the rainfall intensity, you can say, at a particular location.
Location you can say, but it should be in terms of rain gauge only. So
rain
you are
gauge.
having a rain gauge and you are knowing a lat and long value of this station, so you will be getting the point rainfall value in that case. But if once if we want to interpolate this particular rainfall value which have been recorded in this station, so if we interpolate, we can also get the value, like assume this is a rain gauge station value. Okay, we got the rainfall at this location, and if we want to calculate the precipitation value at this, so based on the inverse distance method, okay, inverse distance method, we can compute the rainfall at this. So what we are targeting, we are getting the spatial variability of this rainfall at other locations. Okay, got it?
Yes, I got it.
Okay, so firstly we will be looking into the major concept that is applying behind this method. So you can see ISO height method, it is giving a aerial average rainfall. Okay, now the another point is neighboring station outside the catchment are also considered in this. Okay, so definitely accuracy is getting higher in this case. Then ISO height of various values are then drawn by considering the point rainfall as guide and interpolating between them by the eye. Okay, you got the message from this or not? They are saying that we are having a point rainfall, that is, you can say a rain gauge station data, and they are interpolating. We are if we interpolate those values, we can get the ISO height. Okay. And one more important line is there, that the area between two adjacent ISO heights can be determined by the using planimeter. Now Ashish, for this case we are using isoheightal method, so you may be familiar with this formula. Ashish,
No.
you are not familiar? So so for this question, what we are basically trying, if we are having a catchment of area, let's say A, and we are having an interpolated ISO heights, let's say it is P1, okay, let's say it is P2, let's say it's P3, and let's go on up to Pn. Okay, and also assume that between these ISO heights there is an area of A1, area of A2 is between P2 and P3, and similarly we are going ahead and we are getting the value of An minus 1, because at the last we are not bothered, we are only considering the inner part. So now we are just giving the aerial weightage. Okay, we are giving the aerial weightage to the precipitation values, and we are computing the average value, average precipitation value. Got it? So there is an aerial weightage have been given to this. So now in this case we are having ISO height intervals we have been already provided, and between them there is an area, like you can say A1, it can be A2, it can be A3, it can be A4, or so on. And also like P1 and P2, for P1 and P2 we can also get the value, like if A1 we are considering, so P1, this could be P2,
92 plus 128.
okay, yes. So you can prefer this table as it have been calculated. So first two columns, they are representing the raw data that have been provided in the question itself. Sorry, this first column and third column.
So area, just if we calculate for 15, the first one, 15 to 12.
Yes. So
So
it is,
area is
how much area it has
area,
given? It is given
92
92.
or 92, okay.
Yes, so we are having 92 kilometer square of area. Okay, and then we are getting a fraction of total area, that I was talking na, that we are giving a weightage. So weighted area we are computing. So weighted area will be what? It will be A upon capital A, we can say. So capital A is what? That is a total area.
A
Total
upon
area of
total.
entire catchment.
Okay. Okay, so we say 92 by 1600.
Yes.
Okay.
So how much you are getting? Are you getting this value?
Yes, I got it.
Got it. Okay, then good. Then now what we are doing, we are giving a this whatever the weightage we got, that is the aerial weightage we are getting, we are multiplying with it with the precipitation value.
Okay.
So we already computed the average precipitation value with this area. Okay, you can see, Ashish, that P1 plus P2 upon 2, this is an average value. Do you know, are you getting this?
Yes.
This is an average. So we directly computed these values. Average value.
Got it.
Okay. So let me know whether you are getting the weighted precipitation in the catchment for area of 92 kilometer square.
So yeah, 92 into 5. Yes. No, 92.15. Okay. area into precipitation. Area into precipitation. 0.15
92 multiplied by
into
0.15.
P 13.5.
Value is
Yes,
somewhat
yes, I
difficult.
got it. 2.069. I got it.
You got it. Okay, 02.069. Okay. So likewise, we are computing for the different like other ISO height values as well. Okay.
Hmm.
And once you get the values, come to the formula, come back to the formula again. So you can see whatever the weighted precipitation we are getting for each isohydral interval, at the last we are taking summation of everything. Okay, so
Hmm.
summation of a dot p we can say. So it is
Hmm.
directly giving a value of average precipitation.
Hmm.
So firstly you have to compute iso heights for weighted rainfall for the other iso heights, and then we are taking a summation of this,
Hmm.
and at last we will be getting value of about 7.40. What will be the unit?
Centimeter.
It will be in centimeter. Good.
Centimeter, yeah.
Yes, yes, it will be in good. Now let me check what is the response from Bala Murugan. Okay, average isohydral rain good 7.405. 7.405 good. Which one he is talking? 7 point, yes, right. It will be for 9 to 6, yes. Ashish, let me know if he is replying answer to this question, okay?
Hmm.
Okay.
I'll open this message box.
Yeah. Now we are continuing further. So you may be this question is associating from concept, that is a type of precipitation you may have already
Hmm.
gone through. So it is asking that whenever the rainfall in the area, okay, and definitely it will be passing through the air media, but there is a certain condition that the air surrounding it is at sub-freezing temperature. So which kind of precipitation will occur in the region when there is some sub-freezing temperature condition is there?
This is, I think, snow.
Okay, snow. I guess it is. I guess it is not the right answer. Let's
Hmm.
check. So forms of precipitation. Okay. So we will quickly go
That's
through
late.
some of the basic lines. So rainfall, you already know that the precipitation in the form of water drops. They
Hmm.
may be having water drop dia of somewhat 0.5 mm to 6 mm range. Got it? Then snow, if you are talking, then major point is like ice crystal will be there. Okay, and they are just getting combined to form flakes. And one more important point is that their density may vary between 0.06 to 0.15 gram per centimeter cube. Now if you talk about drizzle, then water drops of size less than 0.5 mm and intensity 1 mm approx 1 mm per hour, it is causing a drizzle. Also one more
Hmm.
thing is there, whenever drizzle will be there, all the drops they are having, they will be floating in the air. This is the condition. One more important part is that one more important form of precipitation, glaze. So when glaze occurs, when it will be having a contact with the cold ground at around 0 degree Celsius. So this is the condition, glaze will occur. And if you are talking about sleet, so sleet will arise when the frozen raindrops of transparent grain form when the rain fall through the air at sub-freezing temperature. So we will be having sleet as this answer, as an answer of this question. Ashish, one more thing that we should look that one more form of precipitation left, that is a hail. So hail is just a irregular pellet or lumps of ice which may be having a size greater than 8 mm. Whenever we usually observe this, okay, in winter season usually, so hails we get sometimes in summer also. Now again the question next question is, dash is a non-recording type of rain gauge. There is one bracket have been provided. You should have idea that what does it mean. Ashish, can you correlate with this? That what just it has been mentioned that pluviometer, there is one more term, ombrometer, then hydrometer is also there. So they are basically a synonym of rain gauge.
Okay.
Yeah. So now there is one question that they are asking about non-recording type of rain gauge. So you
It's
yes,
siphon rain gauge, I think. Yes, it's correct.
non-recording it is asking.
Yeah, non-recording. Yeah, it's Simon's rain gauge.
Yes. Don't confuse with this. Okay. If it is recording, then definitely there will be a siphon action. Okay. And if it is not, then definitely there will be a Simon rain gauge will act. Okay. Okay, so some of the major highlights in this. So whatever the details that are associated with non-recording Simon gauge, it have been provided in the Indian Standard 4986 in the year 1968. You can get these details. Also you can get the dia as like 12.5 centimeter. Okay, this is important because most of the time this have been asked that what is the dimension of this. So you should be having dia as an information, as well as the depth you should have, that how much it is going. So here you can see it is of 25 centimeter approximately, so it will be 250 mm. Now at the last, whatever the water have been accumulated in this glass bottle, we are finally measuring using a jar. Okay. I guess you may be familiar with this already. Then there is graduated measuring glass we are taking. It is having an accuracy of 0.1, and one more thing is that there will be a continuous measurement at 8:30 am only, and it will be giving a cumulative value of rainfall of the entire day. Now again the question is there. I guess you may be familiar now with this question, that mass curve of the rainfall is a plot of.
Yeah, it's an accumulation of precipitation against time.
Yes, you are right. So Ashish, you are right that it is just an accumulation. So summation of P with respect to time. Time will be in hours, and we will be getting a somewhat curve as a rising curve. It will be getting like this. Okay. Okay, you can get this. So some of the major points associated with this. So here one important line is there, that accumulated precipitation against time, it will be plotted in a chronological order. Okay, so it will be an increasing only, like it is going one by one, one after the one, and then again you can see that these particular type of curve, they help in identifying the temporal information of the rainfall. Okay, temporal in the sense what, that we want to know the duration, that how much duration this particular, like if you can say 7 centimeter of rainfall have been occurred in the region, so we are concerned, we want to know the duration of this. So we can get from this, like from this graph itself, like if we project this point, so we are concerned with the 6 centimeter of rainfall. So what will be the time? So we can get this. And one more thing I want to mention, that we already know that this is a curve. So if we take the slope of this slope, if we plot the slope on this curve, so this what will be giving what we are getting from here. So slope will be what? Slope will be a delta p, you can say, upon delta time. So whenever we are taking this, so it is giving us a rainfall intensity. Ashish,
Yes,
it will
yes.
be, what will be its unit? Rainfall intensity, what will be its unit?
Uh,
Here it will be
length versus time.
delta p by time we are taking na.
Hmm.
It
Hmm.
will be a slope, it will be a differentiation. So
Hmm.
differentiation of mass curve, it will be giving us what? It will be giving us rainfall intensity. Why?
Rainfall
Because
intensity.
we are getting the ratio of delta p by delta t, and that is
Hmm.
nothing but it is mm by hour, and mm
Hmm.
by hour is always an intensity.
Hmm.
Got it?
Hmm. Got it.
Yes. And also, as I already mentioned, that whenever there is a constant graph is going, then what does it mean? It means,
इसमें there is no rainfall.
yes, right, there is no rainfall, so no rainfall is occurred in this particular time domain. Like you can say this is in days, so 4, or you can say let's say you can say it is 8, so within 3 days there have been no rain.
Hmm.
Okay, now again question is, you may be familiar with the word consistency check.
Hmm.
Okay, so sometimes whenever the rain gauge we install in the field, there may be a disturbances from, you can say, wind. Okay, there may
Hmm.
be a disturbances from surrounding, like let's say if there will be intervention through animals. Okay, or maybe we are inaccurately measuring the data. Okay,
Hmm.
so definitely there we will be having some error in the observed rainfall.
Hmm.
Okay, and also based on the error, there may be some discrepancy in the accuracy, we can say, right? In order to get the things in right direction, or है then definitely we have to we should have some kind of method so that we can
Hmm.
identify those errors.
Hmm.
Okay, so consistency check is one of those important methods that is used for analyzing the rainfall data we have.
Hmm.
Okay, so now the thing is that why do we need consistency check? The
It
thing
is
I already,
yeah. Number
yes,
one, the unrealistically high values.
yes. So yes, because of an error, it may be possible that we are getting high, or maybe just
Hmm.
lower values we are getting.
Hmm.
Now, can you see other options also? Missing rainfall can be consistency check.
Yeah, missing rainfall data.
Okay, but
Uh,
consistency doesn't allow, like if we want to calculate missing rainfall, then we already have methods now, like
yes,
arithmetic,
yes, we have already a method.
normal ratio method we already have.
Hmm.
So basically it will be a second option as well, a sudden change in the annual precipitation. Okay,
Okay.
it also cause like due to this problem also we use consistency check.
Hmm.
So you can see the explanation that consistency check can be done by using mass curve method or double
Hmm.
mass curve method. So for mass curve method, what we are checking, so we are checking the change in annual precipitation, how much change have been done. Okay, you can see that if we are having accurate data, then definitely it will be going in a straight this straight line. Okay,
Hmm.
and there will be no change in the precipitation, we are assuming. But if the data is getting deviated from the straight line, then definitely we are counting it as just kind of maybe error is there in the observed data. Okay, or maybe there is some kind of sudden change is being done, and what will be the cause of that, we need to figure it out. Okay,
Hmm.
now in parallel double mass method we are also using, okay, to correct the inconsistency. Now we got that this particular year, at this particular year we are having some kind of data error have been noted at particular year. Then how we can correct it? Okay, so in order to correct this we are using double mass curve method. So here in this particular picture you can see that there is a sudden change at this point. Can you note it?
Yes.
Okay, and now in order to correct this we can use similar like journal mathematics, okay, and we can determine the correction factor, and based on that, multiplying the correction factor, we can compute the corrected rainfall values. Okay, so just for your information only. Now coming to the next, so rain gauge density is defined as
Ratio of total catchment area to the number of rain gauge in a catchment. Number 1 is the correct answer.
yes, good. Do you think other options maybe?
No, it's number 1.
Okay, so if they are asking about density, so it's just like total area of the catchment upon number of rain gauge station in the catchment. Okay, and for this density only there have been provisions made at national scale as well as the international scale. For international scale, WMO, that is World Meteorological Organization, it has already gave their recommended values for different topographical areas. Likewise, for Indian conditions also we also have the data. Like now you can see that rain gauge density is defined as the number of rain gauge stations per square kilometer. Like for an area, how many rain gauge stations are there? So it is just like this. And then economic consideration as well as topography accessibility, they always restrict the number of gauge to be maintained in the area. So you can see there is some constraint in this. Now you can also see there is a difference between Indian standard condition as well as the what are the recommended values have been provided for optimal rain gauge condition. So in an Indian condition, in the plain areas we need at least one station for covering the 520 kilometers square of area. Okay, for if we are having an average elevation of 1000 meter, that is 1 kilometer only, so we can allocate one station at an area of 260 to 390 kilometer square. Also for the hilly areas and having heavy rainfall, we need to install at least one station for 130 kilometer square of area. Now what World Meteorological Organization have been recommended, so for the plains they are saying that one station is needed for area of approx 600 to 900 kilometer square, and for the hilly areas one station is mandatory for 100 to 250 kilometer square. So based on this recommendation, usually these rain gauges are installed in the area, in the catchment, you can say. Now coming to the next question. So which of the following term is not used to designate a rain gauge? So I guess now you may be familiar with the question.
Yeah, it's anemometer.
Yeah, what is the purpose of this?
This instrument measure the wind speed, I think.
Yes, right.
Wind
So
direction,
wind
right.
speed it is measuring, right? Wind speed. So here the answer will be anemometer. And the entire remaining one, they are the type of rain gauge only. So you can see there are some pictures which are representing different kind of rain gauges. Like for the pluviometer, it's also a rain gauge only, and you can also say that it is a non-recording type. So this resembles, like in this picture it has been shown, it is just a graduated glass, okay, and whatever the amount of water been stored in this, we are designating it as total rainfall in the area. For ombrometer, you can see there is a steel kind of rain gauge, and similarly hydrometer, you can see from the picture. It is just for your information only, and for anemometer you can see the picture. So there is certain kind of digital setup is there, where electronically we can get the number of revolution, and using the number of revolution with the time we can compute the wind speed. Okay. Okay, now again the next question comes is, how many type of rain gauges are there?
Two types.
Yes, so it is asking only the major rain gauges. So we only have two kind of major rain gauges, that is recording as well as non-recording. Okay. Now can you tell me the name directly for the what are the names of recording gauges, all recording gauges?
Siphon is the non-recording rain gauge.
Yes. Then?
And Simon is the recording rain gauge.
Yes, good.
Weighing bucket type is the recording rain gauge.
Right.
And one is recording.
It will be again a tipping bucket.
Tipping bucket, yes.
Right. So these are the major recording gauges. So these are the few names that you may be knowing, and these one more is there, that is telemetric rain gauges. Additional information regarding telemetric rain gauge is that we can use this rain gauge for remote areas, like if we are having a hill or maybe a mountainous region where we can't assess or we can't go. So simply what we need to do, we have to install it at once, and then we can get the data transferred to your device, maybe electronic device you can, okay, to your system also. So it's just kind of smart rain gauge, okay, which can directly send the data to our system. So we don't need to go each time and see the observation. Okay, so this is one of the advantage of this.
Got it.
Okay, now the next questions come again. The friction between the raindrop and the surrounding air is due to?
It's friction drag force.
Yes, it is friction drag force. So basically it is related to atmospheric water. So whenever the water drop is falling in the air media, so it will be dominated by its weight, that is its mg. Then there will be a buoyancy force which is applied from the air media, it will act, okay. So buoyancy weight will be there, and then apart from this there will be a friction that have been generated from the air. So this is counted in terms of force, drag force. Okay, so some major points you can see that we already saw, that gravity force, that is a weight that is acting, buoyancy, that is due to the displacement of air by drop, and then again friction drag forces. And then you already familiar with other points that have been mentioned, and it is shown that there will be a balance condition will exist with the gravity force that will be equal to buoyancy as well as friction drag force. Now coming to the question again. Now this question is again about computing the average aerial precipitation. Okay, not the point, it is for computing the average aerial precipitation. So in this case it has already been mentioned that we need to use the Thyssen polygon method. Okay. So can you tell that how this Thyssen polygon method works? Can you tell a few points in this?
Yeah, we have to divide. We have to bisect the what they call. We have to draw normal this one,
Yes,
and we have to construct a polygon.
right. So if we are, suppose if we are having a catchment and we are provided with the station, sorry,
Hmm.
we are having a point station in the sense we are having a rain gauge. So let's say
Hmm.
if we are having A, then B, then C, then D. So what
Hmm.
we are initially doing, we are just joining the all these rain gauge stations, okay,
Hmm.
and then we are constructing a perpendicular to each, okay, and
Hmm.
once we are projecting this, then the area that is surrounding the particular station, that is let's see it is a D, so this area will be surrounding this, so we have to compute this area, okay, and then we will be assigning like if once we got the area, we will be assigning the weight, and then we will be getting the average precipitation values. So it is
Hmm.
also just you can say weighted area method, you can also say. So for this case, they are providing the monthly rainfall value. Keep in mind, this rainfall value it is in month.
Hmm.
So for this case, they provided the station like they provided total of 10 stations. Rainfall is also being given in the centimeter, then area of influence they have also so we don't need to construct, we don't need to make any kind of graph, it is already provided that what is the area of influence. So area of influence is for this kind like for let's say if we are taking station D, so area of influence will be this region only, for B it will be to this,
Hmm.
okay. So this is the thing.
Okay.
So let's go through the some details. So
Hmm.
if we are having a catchment boundary like this, and then we are provided with the station 1, 2, 3, 4, you can see up to 6, and
Hmm.
then they have highlighted the bounded area. So bounded area is A1, A2, A3 up to A6, and then they have computed the weightage for each area. And this weightage, how they have computed? So they are computing by putting area of influence at a desired rain gauge to the total area. So this is a total area.
Hmm. I got
Got it?
it.
And this is they are saying it as weighing factor. One more important thing is that Thiessen mean method, we always get the areal average value. I told you. Okay.
Hmm.
Why is it like this? Like you can suppose that we are having this as a Gangetic basin. Okay. Gangetic basin, and entire in Gangetic basin there are maybe I guess 150, if I am supposing it 150 rain gauge stations are there, okay.
Hmm.
Now if we want to compute the average value of rainfall occurring in this entire Gangetic region during monsoon period, so we can compute it using this method. Got it?
Hmm. Got
Okay.
it.
Now one more important thing is that the rain gauge station outside the catchment are also used effectively in this case.
Hmm.
So now we have to go through and we have to determine this. So at least we have to compute for station 1 and 2. Then we can move ahead, because after that we know that the similar principle will be followed for remaining rain gauge station as well.
Okay. Let me calculate it. So P is 30, then it's 4. So that's 249 divided by 4 divided by 249. Yeah, it's correct. 0.0160.
Okay, you got this value, good.
And okay, P. Okay, into we'll multiply by 30. So point 0.48 is no, this 0.0160 0160 into 30 into 30 It's coming 0.48. Yeah, it's coming. Yeah,
Yes, good.
0.48 is correct.
You are getting this. Okay. Now, Ashish, I
Hmm,
want you
yes.
to note one important thing is that once we get the pi into ai aggregated value, okay, we are taking a sum of all these stations like this, and at the last it is divided by entire area of the catchment. Okay,
Hmm.
so it is whatever the table you are seeing, it is just a you can say step by step version to reach out up to this. Okay, so
Hmm.
firstly ai by a they are computing and they are giving it as what is the representation, it is wi. So wi is basically ai upon a, and then pi is multiplying, and then we are summing it for the entire
Hmm.
uh, whatever the stations we have in the catchment.
Yeah, yeah.
So yes, you can also check for the second station, then if you get this, then I can move ahead.
Sure, 1 minute. So 249 6 by 249. 0.024 is correct, and then we'll multiply by 22.530 is correct.
Okay, okay, then good. Can you tell me what Balamurgan is replying?
No, no, he is, I think, not available.
Okay, 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 no issue. Good. Okay, so I'm just taking a last question only. Okay,
Mhm.
so this question is related to isohydral method,
Mhm.
and it is asking about the aerial average precipitation in the catchment.
Mhm.
Details are provided like this: rainfall as well as the ito heights.
Mhm.
Okay, and between the isohydral range of 10 to 20, you are getting the area of 8 kilometer square.
Mhm.
Similarly, 20 to 30, you are getting an area of 30 kilometer square. Likewise, it has been given in the table. Now we are following the same method. Now, Ashish, you have to go through at least two steps. You have to compute and you have to see that whether we are getting this or not.
Just 1 minute. So we need to, for first one is 10, second is 10 to 15. Okay. Okay, 10 divided by 2 to 10 to 15. 10 plus 20. 30 divided by 2 is 15. Then 30 plus 20, 50. 50 divided by 2 is 25. This is okay. I got the average value P.
Okay.
Then average P, P1 plus P2 divided by 2. Then total area 613. So we say 2 divided by 613. 2 divided by 613. Yeah, this is correct. 0.0032.
Okay. Good.
Then we multiply it by P. P is 10 over here. So it's 0.0326. Correct.
So for this getting this value,
1 minute 52.
okay, for getting this value, what you are doing, you are just taking a ratio of I can say ai like a1 upon capital A, right? You are doing this.
Yes, yes.
Okay, good. And then you are finally multiplying it with p.
Yes, yes, yes.
Okay, good. So once you get this value, you have to sum up for remaining iso heights, and you will be getting the value of approximately 52.13.
1
What will be the unit?
centimeter.
Yes, it will be in centimeters. Good.
Hmm.
So from this session, whatever the things we discussed, if you have any kind of query, we can discuss now. And remaining questions, I guess 3 or 4 questions have already it is still remaining.
Mhm.
but we can take it in the next class, and
Sure.
we will try to complete it within time.
Yes, yes.
Okay.
No issue. Okay, no issue.
Okay. Okay, Bala Murugan already left. No issue. Okay, Ashish. Then we will meet in the next session. But I will also add one more thing, that try to solve the questions which are with you in the assignments, or maybe you can also go through few books like K. Subramaniam or maybe Venti Chow. Do you have this additional material with you?
Yes, yes. It's already uploaded in the system. We have
Okay, that's good.
we
Okay,
have books and all that.
good.
I just want to know that in upcoming lecture we how we will find out the highest flood level. It's
Highest flood level.
yes.
Okay.
Generally, what
What what
we
what data they have? Any kind of numerical, or maybe
no, no,
any?
no. It's not numerical. It's general. We do engineering for large solar plants. So we have to identify the highest flood level. We have to determine it.
Okay, so whenever the already many government agencies, like I can say CWC, they
Hmm.
already installed their staffs. Okay, I should say
Hmm.
staff. So they installed it in the nearby the banks. Okay,
Hmm.
you can also say like if you are having a bridge, nearby bridge, you can easily get those staff values. Now what they actually measure, that they used to measure whenever basically flood will come in during the monsoon season, right?
Hmm.
Are you getting,
Yes,
Ashish?
yes. I'm getting.
So basically these staff value, they are measuring it continuously, like in the daily scale, or maybe if there is a scenario of flood, then definitely they will be installing some kind of automotive electronic device, like
Hmm.
just like a sensor. It is just measuring the depth, and it is transferring into the system. So whatever the reading, or maybe a maximum flood value you are getting, it will be,
Hmm.
you can get easily from the any kind of government agencies.
Okay. And we can download CWC data also.
Yes, yes, you can. And even see, Ashish, actually CWC providing the data for two kind of things. Like within India, we have classified as well as non-classified data. So
Hmm.
classified data entirely covers Gangetic Basin. Okay. So this
Hmm.
classified, in order to get the classified data, you definitely have to go through some rigorous process. Like you have to request them, in order to
Hmm.
get that data. But for non-classified, like except Gangetic Basin, you can get the data online only. You don't need to apply. You don't need to request for those data.
Okay, from CWC website.
Yeah. So go with it and try to figure out. You will get the water level. Actually, uh, if I can show you, there is India Varis. Are you getting my screen?
Yes, 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 yes.
Okay. So there is one portal, India Varis. You can also explore this. You can also get the some useful data from here. Like it is showing that utilities. So
Hmm.
publication, then yeah, come to water data, you can see that surface data they are providing, and what kind of
Hmm.
data they are providing, you can see storage, river data they are providing, in river
Hmm.
also, river monitoring they are showing. Even you can
Hmm.
also get the surface water quality. So it doesn't mean that you will get entire data, but yes, whatever the data may be relevant to your study, you can try. And if it is not available in the site, or maybe site, so you can request it from their portal itself. So
Okay.
there is some kind of contact window is also there, you can go with it. Similarly, you can also get the data, you can also explore the data from groundwater. Okay, similarly rainfall you can also get, rainfall, evaporation, evapotranspiration,
Hmm.
soil moisture data. Okay, you can explore this, and you can get whatever data you are looking for.
Hmm.
So like I'm just opening a window for river data. So here it is showing river point data is not available because I have not selected any kind of data. So firstly
Hmm.
you have to select this, you have to go with this, you have to define the source. Source may be in the in what, like what kind of data you want, like for rainfall. If it is rainfall, yes, if it is rainfall, then definitely IMD will be providing you data.
Hmm.
Okay, but maybe yes, source they are showing that yes, if you are looking for Madhya Pradesh surface water data, they can provide. Then you can also give the daily scale of that data and availability of that data. I don't think data will be for much more past year, but yes, for maybe 2010 or maybe 2007 to up to date, you can get those data easily. And keep in mind that there is some kind of abbreviation, sorry, scale they have plotted, that what does it mean you should get. So accordingly you have to download those data. Okay,
Hmm.
try
Got
it,
it.
try it for your region. If you are not getting, then let me
Yeah.
know in the next.
We will discuss in next session.
Yes, of course.
Right.
Yeah.
Okay.
Okay then, Ashish.
Okay.
I'm
Thank you.
stopping.
Thank you very much.
Yeah. Okay. Thank you so much.
Okay.